when we were together on Tuesday, the big takeaway should have been the idea of creating a project. And in the project, you had a specification file that was also known as your header file that had the .h extension. You had your implementation file that contained all of your methods, and then you had your demo file. And in order to put all those together, you should have come up with a .dev file. Now, I know a couple of you were using VS Code. Who was using VS Code? CJ, were you? CJ was. Rashik, were you able to figure out how to get it to work on VS Code?
I got this like plugin, and I mean, it makes a make file and stuff, so you can like run it all in like a project folder. I'm not sure if it'll work for you though, so I'm gonna send it like one to you before for the
Right.
first project.
You'll send the 3 files to me.
Yeah, I'll try that.
Right. Rashik, are you having any trouble?
I'm using the dev.
Oh, you switched over? Okay. Anybody using JGrass? Matthew, were you able to get it to work with JGrass?
I think so. The issue was I had to put it in a separate folder, but I think I got everything running. It looked
Okay.
okay.
Did it create a dev file?
I thought so, but I'll double check.
Okay, just making sure. All right, so when we left off, we were doing 13.3, and I'd asked you to give it a whirl, run through it, and see, create the project, make a header file. You know, we had a couple of things we had to add to the header file. And then when you did the implementation, you had to include that header file. And when you did the demo, you had to include the header file. Does all of that sound familiar? Yep, I'm getting lots of yeps. Okay, so then we're going to move on a little bit. We're going to do a little time jump and go back to, there we go, switch my camera, change my view to speaker, and, oh, that's not me. There we go. This is me. Going back in time to chapter 9 from CPS 161. And why are we going back? Well, this was an important topic that was new in 161, but it's one you're going to use like crazy in 121. And when I say use like crazy, I mean the idea of pointers, okay? Not so much the idea of pointer holds the location of a variable like we talked about, but pointers as in points to a new something. And that something is going to be a struct. I mentioned on Tuesday how structs are really important. So just a quick review of going back to chapter 9 with pointers. And what does a pointer do? Well, you can read it. I don't have to read it, but it points to a memory address. Okay, it holds the memory address of a variable. That can be a simple variable like an int, or what you're going to see in this course, we're going to be pointing to a struct. And there'll be a bunch of different things in a struct. Okay, and one of the things that's in a struct is going to be kind of unique because one of the items in a struct is going to be a pointer that points to another struct. So we're going to be able to keep growing. That's where that dynamic comes into play. So we had the asterisk, and if I remember right, we used it twice, okay? But the second time that we used it was this indirectional operator, and it dereferenced what was at that location and allowed us to change the value. And what do I mean by that? Well, let's start from the beginning. Created a variable X. I have a pointer that points to an integer value, but right now it points to null pointer. Remind me, the version that you folks are using, was it null pointer or was it null here? If you wrote your programs, it was null, wasn't it?
I think it was null pointer.
Null pointer?
Null pointer.
Okay,
Yeah.
so it's null pointer. I think the version I use, it's null. What would be another choice that we could actually put in here that would work? Where in ASCII code is null pointer? It's round.
Zero.
Zero, yeah. 0. Okay, false, 0. You know, that's ASCII code 0. All of that ties in together. So sometimes I think, like I said, my version uses null. And if you submit with null pointer, I just double click on it, make it a 0 and go through real quick and make those changes so that it points to that null. But this is going to become important, this idea of having null available for this course. Okay, so I declared a pointer to an integer. Okay, we're going to be declaring pointers to structs. Pointer equals, this guy right here says pointer gets the address of X. Okay, and all it does is point to where X is. This guy right here, when I put the indirection operator in front of the pointer variable name, it dereferences it and lets me change the value. So just a quick review of what was going on with pointers. Now, adding on to that, we talked a little bit more about how if I look at an array, int numbers 5, this actual numbers, the variable name numbers, was also a pointer. It holds the address of where to start. And then we looked at this as moving over 4 bytes at a time. So really, when I created this guy, I needed 5 times 4, 20 bytes of memory available, and numbers held that address. And when we were doing these, we got a little unconventional, and we said, instead of doing number sub 0, number sub 1, number sub 2, I could store values this way. Go to the address, move over however many blocks of 4 bytes, and then I could put the value there when I dereference it. Okay. And again, array pointer could get the value of numbers, right? It could be assigned the address of numbers. Any questions? We go with chapter 9. I'll take that as a yes. Moving on. All right. So today we're going to jump to chapter 14, start to get into some new things. And we're not going to use these a lot, but I think it's concepts that are important. And when we cover them, some of you are going to go, oh, okay, that makes sense. Now, some of this gets covered more in CPS 230, but some of you may not even still be here in CPS 230. So let's see what we got. I'm going to start in section 14.1, an instance and static member. Okay, oh boy, I'm going to in standard static member. Okay, static member. Down here I have static functions we'll talk about in a minute. Static member, it's a variable. Okay, it's going to be a variable that I put in a class. You know, if I have a class up in front of me, I want to create a variable, but it does not belong to any instance of the class. It's just there, and every instance of the class gets to use it. Lots of big words. Okay, I'd have the door open if we were in the classroom, because people would walk by in one room and they'd hear, well, we're going to add 3 numbers. They'll come by my class. Yeah, we're looking at a static member. It doesn't belong to any class or any instance of a class. So that means, let's look at it this way. Remember back when I had length and width of my rectangle class, and I would instantiate objects, rectangle R1, rectangle R2, rectangle R3, and each one of those R1, R2, and R3 had their own version of length and width. Well, what a static member does, it creates a variable that goes in the class. I'm just going to give it, I'm picking an A. So this is going to be a new type of variable that I can put in a class that there is only one A. R1 refers to this A, R2 refers to this A, and R3 refers to this A. All objects have the same. So if R1 said add 5, it would add 5 to this. If R2 said add 5 to A, it would add another 5. Even though their L's and W's are unique, A is going to be a variable used by all instances of the class. Oh, I still don't get it. So let's see what we have. It's gonna be defined at the end. I want you to grab your books, go in and type in 14.1 on page 819. So for right now, I'm gonna pause the video. I want you to type in 14.1 on page 819. All right, so if we take a look at what you just typed in for 14.1, you notice you're gonna be instantiating three objects here of the class tree. The objects just happen to be called oak, elm, and pine. And every time an object is instantiated, if you take a look back at the class tree, which is just in a header file, which is fine, it can be. You notice that line 18 has my static variable. Okay, in line 5, I declared, I say static int object count. And then at the very end, I say int tree, which is the name of the class, object count equals 0. Okay, object count is not owned by oak, it's not owned by elm, and it's not owned by peat or pine. None of those objects own object count, but they can all use object count. Okay, and as you see, every time I instantiate an object, I call the constructor in line 7 of tree. And within the constructor, there's only one thing happening, and that's the static variable object count gets incremented. And then when I go back to my demo and my main, I can use the one method from tree. That method is get object count, and it returns what the current state of object count is, and it tells me it's 3. Okay, so it's a static variable. Here comes Ken. Ken's not in this class. Hi, Ken.
What do you mean?
Ken,
Yeah, what's up?
you're not in my class. Are you in CPS 162?
Yeah,
As of when?
as of like a while ago.
I don't have you on my roster.
Yeah, I'm signed up for this.
Where were you Tuesday?
I was here.
Really?
I
Yeah.
can't confirm.
You can?
Yeah, he was there.
Yeah. Yeah, he was here.
Yes. Why are you late today?
I've been in here.
What?
Got them typing that code listing.
I can also confirm.
I can confirm too.
What?
It's been quiet. I've been here since like 9:25, dude.
You're gonna have to not be so quiet.
Nice.
All right. So Ken, what's the static member?
What's a static member?
Yep. What we've just been working on.
Yeah, it doesn't like belong to a class or something like that.
All right, that was a quick test.
Yeah.
Who's your favorite 161 teacher?
Oh yeah, you by far.
Did I have you in 161?
Yeah, and we did Java and what was that?
Did you change your name?
It's Kenneth. It's always been Kenneth.
All right, I'm losing it then. I must be
Yeah.
having a bad day. I'm sitting here eating too many non-Perels. I just
Am I not on your roster?
not as of right now.
Nice.
I know, I'm gonna have to go double check.
He is on your roster. He's in the class list.
Yeah, if you're in the class list. When did you add this class? Yesterday?
No, I had it like a month ago.
For real, dude.
Here
last Here's my class list that I printed out
Nice.
end of last week.
Right there I am, Klein Kenneth K.
I thought you said Ken Han.
What?
All right, so somebody's messing with me. Down here in the bottom right, somebody joined the class and it says Ken, H-A-N.
Nice. Well, that is not me.
Yeah, Ken Klein, I know you've been around. Who are you, Ken Han?
Oh, thought you were talking about me. Sorry.
See, I knew I wasn't crazy. I'm eating more non-pro.
Well, I heard Ken. I was like, yes.
Yeah, I know you. Ken, because you sat in the
Oh,
right
okay.
side,
All right. Well, I'm sorry.
in the middle, right. Ken Han, who are you? Huh. Say goodbye, Ken Han. All right, good. I wanted to make sure I wasn't crazy.
All right. Well, I'm sorry for think it was me.
Telling me I'm crazy. All right, let's get back to where we were. All right, so static function. Now, I'm going to see if you guys would understand what a static function is. A static member was a member of a class that wasn't owned by any objects of the class. In fact, I wouldn't have to instantiate any objects and I could use it if I wanted to. Wouldn't make much sense to do it, but take that concept, carry it over to a static function. Oh, I didn't do 14.2. I'm sorry. 14.2 is another example of a static member. I got excited there. I'm all messed up. All right, what I want you to do right now is go to D2L, create a project, get 14.2 and get budget. Okay, any questions about 14.3? Again, we have the static variable. We have the static function. Okay, again, the static function, if I take a look at the static function, it's called main office. And when I look in program 14.3, I see line 17. 17 is the name of the class budget and then the method. It's not tied to any particular object. The method sends in main office request, which is a double that's going in, and that gets added to the corporate budget. In summary, even though static variables are declared in a class, they are defined outside the class. Their lifetime is the lifetime of the program. Again, if I don't have any objects, I still can use my static variable. Static functions can be called anytime, even if an object is never instantiated. Questions, comments, complaints? Not too bad. Okay, on D2L, you have one more set of programs. If you want to go load them up, D2L, load up 14.4 budget and auxiliary. And then I need you to type up 14.4, which is in the book. That's on page 827. What we're going to be talking about with this program is a friend of a class. And we can have functions that are friends, and we can have classes that are friends. And what's that mean to be a friend? Well, what it means is if I declare classes to be friends, then one class can have access to the private members of the other class. So this is a way around of being able to get access to private members of a class. You can create another class that's a friend, or as you'll learn in CPS 230, you can do a superclass subclass relationship, but we're not going to get into that today. We're looking at how to create a friend of a class. You're loading up budget, you're loading up auxil, and then you have to actually type in 14.4. Okay, so I have the recording going again. I'm going to share my screen and hopefully it runs. I have it all in, but so let's see what's going on. So you have an overview of what we're talking about. We're talking about a friend class. So it's a class that has access to another class's private members. Okay, so let's start coming down. And my first question to you would be, okay, if all of this is thrown in front of you like it is right now, where would you start as far as trying to understand it? Again, you have the overview of this idea of a friend class, but where do we go from here? Which one did you start reading first? Any suggestions which one we should look at first? If everybody stays quiet, then I decide, right?
The budget.
The budget, okay. One
I would say the
suggestion.
budget header file. Yeah.
Okay, so let's start with, when we go to budget, I think I'm going to go to the header file. And I'm going to come in because I have an idea of what's going on so far. I have in line 9, there's my static variable still, because we're just building. We're building on what we did in the first couple sections of this chapter. So I have my static member. Documentation helps me with that. And down in line 26, I have a static function that's still going on. And in line 29, I have a friend function, friend void auxiliary office. An auxiliary office is going to allow me to, it looks like I have a method called add budget, where it's going to bring in a value. And you notice it's bringing it in. What do we say? This is a
Address.
the address of an
Class.
of a little bit more than a class
Object.
object of the class budget. Okay, good. So I think let's see, void add budget. That's an inline function. Get division budget. That's an inline function. Get corporate budget. That's an inline function. Okay, so really, as we saw before, when I go to my implementation file of budget, I really only had that one function that needed to be defined. Okay, so I'm looking up at my include statements. I include .h, right? I'm going to come back over here and, oh, look at line 3. I'm including auxil.h. So I'm starting to make the link here so that I can allow this method add budget to be a friend. Okay, so let's take a look at auxil.h. When I come into auxil.h, what do we have going on here? Line 4 is quite interesting. It's a forward declaration of the budget class. Making sure that that is declared before I get into auxiliary. As I come into auxiliary, I'm creating the header file. I see I have first things first. I have a constructor, excuse me. I have what looks like a little inline function. And then I have another function, add budget, which is going to be in my implementation file. And I come in here and I'm talking about working with the auxiliary budget and the division corporate budget. Okay. Division, once again, is an object of the budget class. So when I'm working with this, it allows me, because I said it's a friend, this guy is a friend, I'm allowed to take this auxiliary and add it over to the other budgets. I had it for a while. Now I think it's going away. So let's go and take a look at 14.4. I come in and I'm going to talk about enter the main office's budget request. Okay. I have an array of budgets for the array for the budget objects, an array of auxiliary objects as well. Now, I'm going to stop with that because hopefully you have an idea of what's going on without really confuse you. Because if you start and you look at the documentation, again, this is part of why documentation should start to become more and more important as you go through programming. Get the request for the division office. Now I want to get the request for the auxiliary office. And I know that I still want to be able to get at that static member so that I can have a total budget at the end, which down here I would be displaying the division budget for the offices, the auxiliary budget, and then finally I would be able to display the total budget. There's a whole lot in there of pieces. It's almost like if you printed them all out, you started drawing lines from this line of code over to that line of code, back over to here, and how it all jumps around. But now that you have it, it's all good. You have it in front of you. You can use it. You can use it to support what you're doing. Okay, the next thing I want you to do is go back to D2L, and you should now see a zip folder for chapter 14. This is all of the files that normally would be code listings that you might type up and submit to me, but this is all the files for chapter 14. So go and get that file, unzip it. And then I want you to just open up code listing 14.5. I wish he would call them code listing 14.5. You're going to need rectangle.h, which you would have figured out.
Wait, what do we do when we extract it?
I want you to get program 14.5 to load up and run.
Oh,
And you'll see inside of it, you need rectangle.h. Okay, so what are we looking at in the program you just typed in? 14.3, you had to type in, make it a project because you also had to include rectangle.h and rectangle.cpp, all of which I gave you when I gave you the zip folder for chapter 14. So what's going on in here? Well, we have this equal operator, and it's not equals, it's the assignment operator. And we're taking a look at an assignment operator in C++ can be used to assign everything in one object over to the data in another object, okay? And for example, the one you just typed in and ran looks something like rectangle with its length and its width. Okay, so if I said R1 equals R2, there was a time where I would have panicked because I would have said, uh-oh, not all of the individual things are being copied over. The only thing that's being copied would be, and this came up when we dealt with strings, the address of the string. Like if I said str1 equals str2, they would now both point to the same memory address, not what was in them copied over to two different memory addresses. Okay, so that makes me worried when this is where I start learning too much. I start to get dangerous. Will this work? Well, C++ did the override. Okay, it's a word we're going to use later. They did the override so that if I have one object, R2 being assigned to another object, it would copy over the lengths and the widths. Now, this is called shallow copying. Okay, in a sense, it's shallow copying because I'm only copying over the values. Well, what if I had a class and I called it student? Okay, and in my student class, I had a string that's a name and I had an array of 10 scores. And if I did S1 equals S2, well, by definition, what happens is the address of the string would get copied over and the address of the arrays. I wouldn't get the individual values like I did over here because I have different types of data stored inside. So this is where my problem comes with deep copying, where I have to not do the S1 equals S2, but I have to copy everything over. And there's going to be two solutions for this. The first solution is, okay, Dev, I got it. The first solution is something called a copy constructor. The second solution is going to be operator overloading. And some of you got operating overloading in 121, some of you didn't. It was just conversation, started to get to that extra for experts. But I need a way not to just do R1 equals R2 and the length copies its value over, the width copies its value over, but I need to be able to be prepared to handle things like, I don't want the address of name copied. I want to copy the whole string and I want to copy the whole scores. So what we're going to start on Tuesday is coming up with a solution for this deep copying idea by creating what's called a copy constructor, and by then moving over to something called operator overloading. Can you tell me off the top of your head, back from Java, an operator that was overloaded? I'm going to give you a hint. It looks like this. What's that operator?
Addition.
Yeah, it's addition, right? Addition. And addition was able to handle a lot of different things. It was able to handle 4 plus 2, an integer, and I added to an integer. Okay. It was able to handle 6.1 plus 11.5. It was able to work with this. How else was it overloaded? Well, if you remember when I would work with strings, the plus sign was a concatenation. It allowed me to take one string and append it to the end of another. So this plus operator had a lot of different different uses. Adding integers, adding mixed data types, okay? Adding strings to concatenate them together. Well, we can take care of an operator like the assignment operator. And what we're going to learn on Tuesday is how to overload that to give it a new, depending on what I'm using on either side of it, use of that operator. Okay, so we're going to change it so that if I do have this, I know to copy, because this is an object of student. This is an object of student. How does it work? We're going to lay that out and put it in the class. So if that comes up, we'll be able to get all of the data copied over.
Do you mind pushing the piece of paper up just so that
This way. Push it real good. Okay, any questions? All righty then, everyone have a good weekend. We have 1 week down and 13 to go. And I will see you on Tuesday.